Good afternoon, everyone. Welcome to today's class. Okay, so let's see people that's online. Faiza, hi, Prevail. Joseph, you're welcome. Please, can you see the two lines on the board? Can you see the two lines on the board so that we can start? Okay, Faiza, I can't. Okay. Can you see it now? Osakwe, can you see it now? Bless Nosa, you're welcome. How are you today? Anoze Choma, how are you today? Okay, Faiza, I can see it. Wendy, how are you? Okay. All right, so we can start. Victoria Charles, okay. Wendy, how are you? All right, the topic we're going to discuss today is speed, velocity, and acceleration, okay? So I want you to stay tuned so that I can understand the concept of speed, velocity, and acceleration. Let's go. All right, so we have speed. What is speed? Speed is defined as the rate at which a body covers a distance. Okay? So now, if a body wants to cover a distance, let me say this is point A, and this is what? Point B, right? If you calculate the time taken, the distance from here to here, let me assume it is 4 meters. Okay? And if it takes the body 2 seconds to cover this distance from A to B, we are asked to checkmate our what? Our speed. You get it? Now, if a body moves from this point to this point, it's a distance of what? 4 meters. And it took that body 2 seconds to cover that distance. We can calculate the speed of the body. What am I trying to say? The rate at which a body covers distance is said to be what? Our speed. Okay? So, we can say that speed is a scalar quantity. Why is it scalar quantity? It's a quantity that has only magnitude with no direction. We can ascertain the magnitude of the body with respect to speed, but we can't say much about direction because it does not have direction. Okay? All right. So we can say that speed is equal to distance over time. The speed is equal to distance over time. Can we talk about the unit of speed? Unit. Distance is measured in meters, right? While time is measured in what? Seconds. Okay? Now, you remember I told you earlier that we can't leave unit like this. We have to carry it up to the numerator. And because it's in the denominator, it's going to come up with a negative sign. This one already has power of 1. Now, as soon as you carry it, it's going to carry a negative sign. That is mx minus 1. Right? And that is what is said to be what? Meter per second. Okay? So, say it this way. meter per second. Okay, that is the unit of speed. Meter per second. Meter per second. Okay. Now, what if we are asked to find the dimension of speed? We have done that before, but we are asked to find the dimension. This is meter. Meter is measurement for length. So just write what? L. This is seconds. Seconds is measurement for time. Just write T power minus 1. Is that okay? So this is all we can say about what? Speed. Also, when the body covers average speed, I'm still going to explain that concept. Put it down. Faith Okiraja, you're welcome. How are you today? Progress, God's power, you're welcome. Osakwe, you're welcome. Evelyn, you're welcome. Addison, you're welcome. Please write what you have on the board. Please, if you are just joining us, give it a thumbs up, okay? And make sure you subscribe to this channel. Give it a thumbs up. Hello, you're welcome. How are you today? Treasure, you're welcome. How are you today? If you are just coming, give it a thumbs up, okay? Are we done? Are we done? Okay, Chidera, fine. Are we done? Alaba done. Blessing, you're still writing. Faiza done. Okay, Ogechi, we should continue. Ajoku, you're welcome. How are you today? All right. Average speed becomes change in distance divided by what? Change in time. We have two different distances. You can checkmate it and get the change. And that will help you to get it, also the change in time. and for you to calculate your average speed. Okay, this can be written also to be what? Final distance minus initial distance divided by what? Change in time, right? Change in time. Okay? Do you understand? All right. Remember that I told you that speed is measured in meters per second. A situation whereby our unit of speed will be given in kilometers per hour. What do? We need to convert. Okay? After conversion, we can now solve. For example, if I say this is conversion of kilometer per hour to meter per second, right? If I am given x, and x is a number, and that x is given in kilometer per hour, now I am expected to convert it to meters per second before I solve. So what do? I'll say that x times 1000 divided by 60 times 60. Okay? So whatever thing we have, it will now give us in meters per second. Do you understand? Okay. So we can try an example. But if I proceed, 1 kilometer is equal to 1000 meters. 1 kilometer is equal to 1000 meters. Okay? And 1 hour is equal to 60 minutes because 60 minutes makes 1 hour. And for us to convert that minutes to seconds, multiply by 60. So it's the same thing as saying 1 hour is equal to 60 seconds times 60 seconds. Okay? So this is what we have. Now, this is the way we arrive at this formula by saying if you are given any value in kilometers per hour and expected to work on the speed, what you are going to do is to convert it to meters per second by multiplying the value by 1000 and dividing by 60 times 60. Whatever thing you have, the answer will be in what? Meters per second. And you should know this before we proceed with this topic. Okay? Right. Now we are going to solve an example of this. If I say, for example, convert 108 kilometers per hour, I am expected to convert it to what? Meters per second. What do? This is the number given to us, and we are giving it in kilometers per hour. And before we can solve, we need to convert it to meters per second before we solve. All right? So what we do is to say this is 108, right? Multiply by 1000, then divide by 60 times 60. Okay? Now, whatever thing we got at the end of this multiplication and division is going to be in meters per second because we've already converted it. Now, going by that, 0 cancels 0, 0 cancels 0, right? All right, 2 can divide. 2 divided, you have what? 3. 2 divided, you have what? 5. Are we together? All right. Can 3 divide itself? 1. Can 3 divide 10? I have to remember what? 1. I'll add it, that is what? 18, right? If 3 divide 18, what do I have? What do I have? I will have what? I will have 6. If 3 divide 18, I will have 6, okay? Now, 6 can divide itself 1. 6 can divide what? 6 into 6 is going to give me what? 6. So I'm left with 6 times 5. And 6 times 5 is equal to 30 meters per second. So if you are converting 108 kilometers per hour, it's going to give us 30 meters per second, okay? So we're actually solving with 30 meters per second. Do you get it now? Right. Okay, Andrew, I should repeat. Please give it a thumbs up if you are just joining us. Give it a thumbs up, okay? Fine, that's how I should explain. I will explain again. Now I said that the average speed is equals to change in distance over change in time, okay? Now the change in distance means if you are given two different distances, you have final distance minus initial distance, okay? Now you get the change in time, that becomes your average speed. Now, and I said that the unit of speed is measured in meters per second. But there'll be a situation whereby you see the unit of speed to be in kilometers per hour. What are you supposed to do? You're supposed to convert it to meters per second before you solve. And that comes this formula. And I said, for example, we are given x, and x is a number. X is given in kilometers per hour, and we are expected to convert it to meters per second. What do? We are going to say x, which is that number given to us, multiplied by 1000, and divided by 60 times 60. Okay? So how did I come about this formula? And I said that 1 kilometer is equal to 1000 meters. And remember, this is a kilometer, 1 kilometer, right? And I'm converting it to meter. So I'm multiplying by what? By 1000. Okay? And this kilometer per hour is the same thing as saying kilometer over what? Hour. Do we understand? So then this hour is equals to what? 1 hour is equals to 60 minutes, right? And for me to convert that minutes to seconds, I multiply by 60. So it's just like saying in 1 hour we have 60 times 60 what? Seconds. That means in 1 hour we have 3600 seconds. Is that okay? And whatever thing we have at the end of the day, you need to now change to the meters per second. That means you have converted it. Do you understand now? And I gave you an illustration. I said, for example, convert 108 kilometers per hour to meters per second. Now, how do we convert this? It's simply by saying 108 multiplied by 1000 and divided by 60 times 60. Okay? Whatever thing you have, we give you in meters per second. So let's do our division. 0 cancels 0, 0 cancels 0, right? I said that 2 can divide 6 to give me 3. Y2 can divide 10 to give me what? 5, okay? Y3 can divide itself 1. 3 can divide 108 to give me what? 36. I have 6 here. 6 divide itself 1. 6 divide 36, I have what? 6. So I'm left with 6 times what? 5, okay? By the time you multiply, the answer becomes 30 meters per second. That means you have already converted it to what? Meters per second, which is the rightful unit of speed. Is that okay? Right. Progress, how did you get 1000? 1 kilometer is equals to 1000 meters. Okay? Because I'm converting from kilometer to a meter. All right. Faiz, I understood better now. All right. So let me give you something to try, okay? So that I'll be sure that you can actually solve this conversion very well. Miraba, you're welcome. How are you today? Okay, Chidera done. Faiza done. Evelyn done. So let's proceed. Also, is little. Are you sure it's not from your network? Can you change your position where you are right now to see if it's going to pop up well? Also, we're done, so we can proceed. Now let me test your ability. Okay, we're done. If you can actually do this before we forge ahead. Okay, also I understand. Okay, that's good. Ajako done. Please, can you try this example on the board and see if you're going to get it and drop your answer? You have 2 minutes to do that. Right. If you cancel out in the calculation, you will not arrive at x. Cos power x I wrote there is a number. The x is a number, okay? What I'm actually looking at is the unit obtained. Okay, Addison, you got 20. Is it 20? Is it 20 meters per second? And was they done? All right, Addison, 20 meters per second, okay? So, okay, 20 meters per second. Okay, wait, 20 meters. Okay, wait, 200 meters per second. Five is at 20 meters per second. Upper like 20 meters per second. Ajoku 20 meters per second. Evelyn, you got 20, okay? Prevail 20 meters per second. All right, all right, all right. Kevin, I see you. Treasure. Okay, I got you. Evelyn, treasure, okay? Blossom, Kenneth, 20 meters per second. Please, more of that, ma. No, we have a lot of things to talk about today, so we just forge ahead. So let me just solve it to confirm our answers, okay? So we can proceed. All right. Okay, so I'm giving to convert 72 kilometers per hour to meters per second. So let's proceed with the solving. This is simply by saying 72 times 1000 divided by 60 by 60, right? Now what will cancel? 0 cancel 0, 0 cancel 0, right? 2 into 6 is going to give me 3. 2 into 10 is going to give me what? 5, okay? Now let's see if 3 can go into this. 3 into itself 1. 3 into 7, I have 2, remainder 1, add it here, that is 12. 3 into 12, that is what? 4, right? I'm left with 6. 6 into itself 1. 6 into 24 is going to give me what? 4. So I have 4 times what? 5. By the time you multiply, the answer will be what? 20 meters per second. Is that okay? All right, the answer to this question is 20 meters per second. All right. Obedience, are you just joining us? Okay, obedience, we're going to solve more and more examples. So we want to start solving example. What I just did now is to do conversions from kilometers per hour to meters per second. Okay, so let's move into the real question. All right. Now we have this example on the board. It says a student walks a distance of 3 kilometers in 6 hours. Calculate its average speed. Let me go again. A student walks a distance of 3 kilometers in 6 hours. Calculate its average speed. So what we are going to do now is to set our parameters. Our distance, which is equals to 3 kilometers. Then my time, which is equals to what? 6 hours, and I'm looking for average speed. Then what is speed? Speed is equals to distance divided by what? Divided by time. Okay? So what's my distance? My distance is 3. That is 3 kilometers. 3 kilometers over what? 6 hours, right? Now if you divide with our calculator, say 3 divided by 6, my answer is going to be what? 0.5 kilometer per hour. That is my answer. But I'm not yet done. I am to calculate and change this speed from kilometers per hour to meters per second. Okay? Speed is equals to 0.5 times 1000 divided by 60 times 60. Okay? You can equally use our calculator to convert or to multiply. 0.5 times 1000 is equals to what? Is equals to 500, then divided by what? 3,600, okay? Now this is 500 divided by 3,600. Now what do I have? The answer to this question is 0.138 meters per second. I hope you understand. Now let me do a recap. A student walks a distance of 3 kilometers in 6 hours. Calculate its average speed. Now, knowing that my speed is 3 kilometers and my time is 6 hours, and the formula for speed is distance over time, the next thing I'm going to do is to substitute it into what I have by saying that distance is 3 and time is 6. Okay? By the time you divide, you're going to get 0.5 kilometers per hour. That is what we have in the question. But we are supposed to convert it after solving to meters per second by using this formula, which is what? 0.5 times 1000 divided by 60 times 60. Okay? And I said you can equally use calculator to do that. By saying 0.5 times 1000, you're going to give me what? 5000. Okay? 60 times 6 is going to give me what? 3,600. So by the time you divide, what do you have? You have 0.138 meters per second. Is that okay now? Right. Do you understand? Thank you so much, Ejawoyinka, for coming. All right. Olebube. I'm actually calling what I'm seeing there. So that's just it. You're welcome. Please, do you understand what I just solved? Hezekiah, you're welcome. Oh, he gives. Okay, got 20 meters per second. That's good. Please, do we understand? Put it down, please. Let's proceed. Are we done? All right. Sorry, my chat was hidden. Sorry. All right. So let's proceed. Oh no, I just come in. I just come in. Okay, we are solving more of examples, okay? I believe you understand. So just stay tuned. You will certainly understand. want to say where does 60 comes out from? Okay, I've already explained that if you want to convert minutes to seconds, you multiply by 60. Okay, then if you want to still convert hour to seconds, you still multiply by 3600. So let's solve. Okay, let's solve. A driver traveling at a speed of 115 kilometers per hour received a text message on his mobile phone. A driver is traveling at a speed of 115 kilometers per hour received a text message on his mobile phone. How far is he? How far is he 20 seconds later from when he received the text? How far is he 20 seconds later from when he received the text? So the first thing we are going to do is to get the speed, of which our speed is giving us 115 kilometers per hour, right? Okay, then the time is giving us what? 20 seconds. Now, if you hear how far means what? Means distance, okay? How far in physics means distance, but if we are asked how long, means time, okay? How far means distance, and how long means time. All right? Okay, so we are looking for how far. That means we are looking for distance. So we are looking for d. Our d is unknown. Now, what do we do? What you are going to do before we solve, the time here, this is kilometer per hour. Why the time is in seconds? So we need to convert this speed, unit of speed, to be in meters per second before we can think of solving for our distance. So with that being said, we now proceed by saying speed is equals to 115 times 1000 divided by what? 60 times 60. Okay? So you just have to multiply. 115 times 1000 is going to give me 115000, okay? Divided by 60 times 50, that is 3600, okay? So let us divide. The answer will be 31.94 meters per second. That is my speed. Okay? Now, I've gotten this speed. The next thing is to get our distance. And remember that speed is equals to distance over what? Distance over time, right? Now, I've gotten my speed to be 31.94, right? Is equals to, I'm looking for distance and my time is what? 20, right? Now, can I do cross multiply? Cross multiply. My distance is equals to 31.94 multiplied by 20. So use our calculator, multiply by 20. So my answer becomes 638.8 meters. Okay? So the the answer is what? 638.8 what? Meters. Do you understand what I did? The speed is given in kilometers per hour. You cannot solve for distance without changing this what? Speed. And I've told you how to convert it to meters per second. Why are you converting it? Because this time is in what? Seconds. So you need to convert it to seconds, okay? Now what do we do? It says speed is equals to 115 times 1000 divided by what? 60 times 60. By the time you multiply, you get 1,115,000. This one is going to give me 3,600. You now divide to get the speed to be 31.94 meters per second. Without forgetting that the formula for speed is equal to distance over time. So what is my speed? I've gotten my speed to be 31.94 is equal to distance over what? My time is 20. So cross multiply. D times 1 is D. 31.94 multiplied by 20 is going to give me my distance to be 638.8 meters. Is that okay? Right. All right. Please, do we understand? All right. I should recap. Okay, let me go again. A driver traveling at a speed of 115 kilometers per hour received a text message on his mobile phone. How far is he 20 seconds later from when you receive the text? Okay, so we are giving the speed in kilometers per hour, so you need to convert because of this unit to make it to be in meters per second. So what's my time? My time is 20 seconds, okay, from the question. And how far means what? Distance. Whereas how long means time. Okay, so what do we have? You say this is speed is equal to, for us to convert this to meters per second, we are going to say 115 multiplied by 1000 divided by 60 times what? 60. Okay, by the time you multiply, this is going to give me 115,000 divided by 3,600. So what do? We divide to get 31.94 meters per second. This is just to solve for my speed. So the next thing I'm going to do is to get the distance, which is what I'm looking for. And I must not forget that speed is equal to distance over what? Time. Okay? So my distance gotten is 31.94 is equals to, sorry, my speed gotten is 31.94 is equals to, I'm looking for the speed, the distance over time. So I do cross multiply, d times 1 is d, and 31.94 times 20 is this, and my answer becomes what? 638.8 meters. I hope you get it now. Right. Yes, I cross multiplied. Progress, I cross multiplied, okay? Do we all get it now? So let's move into another thing. Are we done? Okay. Okay, please concentrate. Are we done? All right. So let's look at this. Uniform speed is when a body covers equal distances in equal time interval. No matter how small the time interval may be, the speed is said to be what? Uniform. How do I mean? Okay, so whenever our distance and time are equal, or whenever a body covers equal distances in equal time interval, is said to have what? Uniform what? Speed. The body is said to undergo uniform what? Speed. So don't forget, whenever there is equal distances in equal time, the body is said to undergo what? Uniform speed. Okay, so you should note the slope of distance time graph is called what? Speed. Okay, this is time and this is distance. So this is my origin. So the slope is equal to what? Speed. The slope is the same thing as the gradient. And how do you get the slope? By finding the difference here, here, and here. Okay? This is your T1, this is your T2, this is your D1, this is your D2. Okay? Now getting the difference between them is going to give you what? Speed. Slope is like gradient in mathematics. Getting the difference between them, change in velocity over change in what? Time. Okay? That is going to give us what? The slope. Is that okay? Right. Treasure. Concentrate. You know why you are here. Addison, you don't understand. Let me explain again. Okay, I said uniform speed is when a body covers equal distances in equal time interval. No matter how small the time interval may be, the speed is said to be what? Uniform. Uniform speed is equal to when a body equal distances in equal what? Time. That is uniform speed. We already know that speed is distance over time. But when a body covers equal distance in equal time, the speed is said to be what? Uniform. And I went ahead to say that you should note that the slope of distance time graph is what? Speed. Time graph is what? Speed. So when you plot a graph of distance against what? Time. This is the distance axis. This is the time axis. You don't have to find the gradient in math. Then you have to find slope in physics, okay? So this is your zero, which is origin. So this is the straight line passing through the origin. Then this is my what? This is my gradient. So the slope is equal to what? Speed. So how do I get speed from this? I will take it down and take it down. This is T1, this is T2. This is D1, this is what? D2. So if I'm going again, I can say that speed is equals to change in D over change in T. That is D2 minus what? D1 divided by what? T2 minus what? T1. That's what I mean. By the time you find the difference, the answer is going to give you what? The speed. And this is what we call the slope. Okay? This is what we call what? The slope. Right. All right. Is it okay now? All right. Are we done writing? No, the last one I talked about now is the slope. Okay? Yeah, Delichi, you are just coming. So after the class, you can watch the video again. Please, are we done? So we can proceed. If I warn you again, I'm going to remove you right now and you not join my class again. Final warning. Are we done? Are we done? All right, files are done. Isn't it you're welcome? How are you today? In the more Chinwe, how are you? I hope you have subscribed to this channel. All right, give it a thumbs up, okay? Victoria Charles, give it a thumbs up. Okay, done. Ma. All right, let's look at this. Velocity is defined as the rate of change of displacement with time. Velocity is defined as the rate of change of displacement with time. Now, what is displacement? Displacement means distance traveled in a specified direction. Displacement means distance traveled in a specified direction. Okay? Now, what is velocity? Velocity is displacement over time. And since displacement has direction, I've already told you how to calculate it in the last video. All right. What is velocity? There is change in displacement over change in time. That is equals to my final displacement minus what? Initial displacement divided by final time minus what? Initial time. Is that okay? Right. Thank you, Vijaya. Thank you so much for coming. I really appreciate. You're welcome. Are we done, class? Are we done writing? Are you done? All right, okay, we're done. Let me explain. All right, when a body covers equal displacement in equal time interval, no matter how small the time interval may be, the speed is the velocity is set to be equal. Let me just add it. Is said to be uniform. Okay? All right. Honey, you're not seeing properly. Is it from your network? Why does it have three formulas? Which one has three formulas, please? Osako, which one has three formulas? Why does it have three formulas? Oh no, it does not have three formulas. We just discussed speed and we are done with speed. Now we are coming to velocity, okay? We are coming to velocity now and we are in velocity. Velocity is distance, is displacement over time, whereas speed is distance over time. Okay, it does not have different formulas. It's just that when you are giving two values, when you are giving difference when you are giving difference in displacement, for example, the first displacement and the second displacement, so you are going to find the difference. That becomes the change. Okay, that becomes the change. That does not mean that it has two. It becomes the change. It's a change you're looking for. That's if there is. If there is none, you only use one. I'm going to summarize everything to you. Vijaya, they are just students. They don't have channel, okay? All right, so I'm going to explain everything again to you. I'm going to summarize everything so that I don't get confused. Do you understand? Okay. If I say that velocity is equals to displacement over time, so let's get the unit. Displacement is measured in meters and time is measured in seconds, okay? So the unit of displacement is what? Meter per what? Second. So you should note velocity is a vector quantity. Velocity is a vector quantity, so it has magnitude as well as what? Direction, okay? Now the slope of velocity time graph is called, it should be displacement. Displacement time graph is called velocity. Okay. So unit of velocity is meters per second, and it is a vector quantity because it has magnitude and direction. Then the slope of displacement time graph is called what? Velocity. All right. Chinwe, the network is really bad. So sorry. But is it okay now? Magnitude is the same thing as size, Faiza. Magnitude is the same thing as size. It has size. You can measure the size, okay? That is the mass. That's what I mean by size. You can measure it. You can check your location or change your position where you are sitting. Maybe network is coming from there. Okay, so are we done writing? Let's go into acceleration before we start solving problems. Are we done writing? All right, okay, Chiku, we are done. Okay, where are you done? It's a vector quantity because it has magnitude and direction. It's a vector quantity because it has magnitude and direction. And it's also a vector quantity because displacement is also a vector quantity. Okay? Displacement, you must get the magnitude and direction. You know, we have done displacement in the previous video under position, distance, and displacement. I told you how we can get the displacement of a body by finding the angle and the direction of the body. Okay? So if you don't know how to do that, you can check our previous class on position, distance, and displacement. There you can get how to solve for displacement and know why it is a vector quantity. All right, let's proceed. All right, let's write what is on the board. I want to start explaining it. Okay, let's explain. Acceleration A is defined as the rate of change of velocity with what? Time, okay? The rate of change of velocity with time. It is a vector quantity because it has magnitude and what? Direction. So acceleration A is equals to velocity change over what? Time. Okay? What's the velocity change? What brings about the velocity change? When we have two different velocities, okay, we subtract it to get the change. That is final velocity minus initial velocity, then divided by what? Time. Is that okay? All right. Now, this my change in time. I can say final time minus initial time. Okay? Now, the final velocity is denoted by final is denoted by V. Initial velocity is denoted by U. And time is denoted by T. Now we can generate by saying that acceleration A is equals to V minus U divided by what? T. So this is the formula we are going to use to calculate our acceleration. Acceleration A is equals to V minus U over what? T. What is U is initial velocity and T is what? Time. Is that okay? Right. Okay, progress. Say it means the explanation velocity. Okay, summarize it after this one so that we can do the solving at once. I'm going to summarize it after this one. All right, Victoria. Okay. Okay. All right, but then copy what you have on the board. Let's proceed. I'm going to go back to that one. Are we done, class? I will explain it again. Hold on, the unit of acceleration is meter per second square. Are we done? Are we done writing, please? All right. Okay, since we said that acceleration A is equals to velocity change over time, let's talk about the units. The unit of velocity is meters per second. Okay? The unit of time is what? Second. Then if I carry this second up, I'm going to have what? Meter per second square. That is meter per second square, okay? Now, acceleration can also be defined as when the velocity of the body increases with time. So let me state it. Note, when the velocity of a body increases with time, it is called acceleration. When the velocity decreases with time, it is called deceleration. Or retardation. When the velocity increases with time, it is called acceleration. But when the velocity decreases with time, it is called what? Deceleration or retardation. That means deceleration is a negative of acceleration. Okay? So, right, I'm going to explain it. Are we done writing? Are we done writing? So I say that acceleration is velocity change over what? Time. Let's talk about the unit. Since the unit of velocity is meters per second and time is second, okay? I'm going to carry it up to half meter per second what? Square. So this is meter per second square as the unit of acceleration. Now you should note, when the velocity of a body increases with time, it is called acceleration. But when the velocity decreases with time, it is called what? Deceleration or what? Retardation. So, deceleration is the negative of acceleration. Even though in a question, when you're looking for deceleration, you're actually looking for an acceleration, but it's going to have a negative sign. Okay? So, the unit is the same thing as acceleration, which is meter per second square. Do we understand? Right. All right, Honor, why is it like that? Okay, that is how it is done. If I use a velocity time graph to explain for you, you're going to see what I mean by acceleration and what? Deceleration. When a body is increasing, it is said to be accelerating. When a body is decreasing, it is said to be what? Deceleration. Okay? So I believe we are done now. All right. Charles, I'm trying to explain it again with a diagram so you understand better, okay? I want to explain about retardation right now. So let me just proceed. diagram. This is what we say called to be velocity time what? Graph. Velocity time graph. Now, when this is 0, when the body is moving, it's said to be accelerating. And when the body starts from rest, our initial velocity u equals 0. So when the body moves from here, it accelerates. Okay? So this becomes uniform what? Acceleration. Because the body is what? Moving up. Okay? The body is accelerating. When on this horizontal, the body is said to undergo uniform velocity. Because the body is no longer moving up, okay? And when the body is going down, the velocity of the body decreases to rest. This becomes uniform what? Deceleration. And the body is coming down to rest. You get it now? So acceleration is when the body is when the velocity of the body increases with time, that is acceleration. But when the velocity of the body decreases with time, that is what? Deceleration or retardation. Do you understand? When the velocity of the body increases with time, it is called acceleration. But when it decreases with time, it is said to be what? Deceleration or retardation. So if I say that retardation or deceleration is a negative of acceleration, even though the unit is the same as acceleration, which is what? Meter per second square. Do you understand? The body is decreasing. So this is uniform deceleration because the body is going down. But here the body is going up. That is what? Uniform acceleration. So you see the difference between acceleration and what? Deceleration. Acceleration, the body is going up. Deceleration, the body is what? Coming down. Do you understand? All right. You should note when a body starts from rest, its initial velocity u is equal to 0. Honor. Why is it that when solving, you don't carry the minus sign along? Is it because of what I solved yesterday under friction? Okay, you know, I talked about deceleration yesterday. When the body was decreasing, we got the acceleration as minus. We are not using it, okay? We are not using it to solve. But depending on the question asked, by the time we solve 1 or 2, you should be able to know how we can fix. You can be able to solve it, okay? How does the body increase? How does I say the velocity of the body increases? I didn't say the body increase. The velocity, which is the rate at which the body moves. Okay, the velocity of body increases. Okay, all right. Actually, there are the class also end. Okay, we should be ending by. Should end by 4:30. I want to solve problem. Just I need to explain for everybody to understand. But even if your battery went off, you can still watch the video when I upload it. Okay. All right. So we can proceed. We can proceed. Okay. So let me explain what I have on the board. Now let me go again. When the velocity increases, the velocity of the body increases with time, it is called uniform acceleration, okay? Or when the velocity of the body decreases with time, it is said to be what? Uniform deceleration. Now you should note that when a body starts from rest, its initial velocity u is equal to what? 0. This is rest. When the body starts from rest, know what is rest? The body was at a point before it started making movement. So its initial velocity before the movement becomes 0 because it was at rest, okay, before moving. All right. When the body did not start from rest, the first velocity given becomes the initial velocity. If this particular body did not start from rest, the first velocity given becomes the initial velocity, okay? So we're going to solve problem on velocity and what? Acceleration. Right. All right, are we done? Let's solve problem. Are we done? Let's solve problem. All right, files are done. Okay, thank you so much. Please, can you copy what you have on the board? Let's solve together. We'll soon end the class. Just two examples, then give you classroom. All right. Okay, let's solve. The speed of a bus increases uniformly from 15 meters per second to 60 meters per second in 20 seconds. Calculate its acceleration. Let me go again. The speed of a bus increases uniformly from 15 meters per second to 60 meters per second in 20 seconds. Calculate its what? Acceleration. Now, for us to do that, we must set our parameters. My initial velocity becomes the first one, which is what? 15 meters per second. Okay. Then my final velocity v is equals to 60 meters per second. Okay. And my time t is equals to 20 seconds. Calculate its acceleration. We are looking for a. And what's the formula for a? A is acceleration is equals to v minus u all over what? T. Okay. So my a is equals to, what's my final velocity? I have 60 minus initial is what? 15 divided by time is what? 20. Okay. So by the time you subtract, what do you have? You have 45 over what? 20, right? So by the time we divide it, let's see what we'll have. 45 divided by 20, the answer A is equals to 2.25 meters per second square. Do we understand? Now we are given two different velocities. The speed of a bus increases from 15 meters per second to 60 meters per second in 20 seconds. Calculate its what? Acceleration. So what is my u, which is the first velocity given? It's given as 15 meters per second. And final velocity is 60 meters per second. And time is 20, right? So we're asked to calculate the acceleration. So for us to calculate the acceleration, what are we going to do? Our formula A is equals to v minus u over what? T, right? What is my v? My v is 60 minus 15 divided by what? Time. When I subtract it, I got 45 over what? 20. And I divided to get 2.25 meters per second square. Is that okay? Right. Obedience. Okay, we are not doing calculation on velocity. Velocity and acceleration, most of the times they come together, okay? They can give you the questions together. Okay? All right, so copy, let's proceed. All right, we are done. All right. Okay, let's solve. Victoria, I'll give you the final warning. Let's solve the next question. Okay, well, what's the meaning of that? Kewe, I don't want to see that again. Please, I don't want to be seeing that greeting pleasantries they are exchanging here, please. I don't want it. I'll just remove you immediately. You can do that in your WhatsApp group, not here. Hello, you're welcome. Are we done with the question? All right, so let's proceed. A train has an initial velocity of 44 meters per second, okay, and an acceleration of -4 meters per second square. Calculate its velocity, okay? Let me go again. A train has an initial velocity of 44 meters per second and an acceleration of -4 meters per second square, right? Calculate its velocity, okay? All right, but we don't have time. Let me check the question again. Calculate its velocity after 10 seconds. So let me add. Okay, so calculate its velocity after 10 seconds. What you are going to do is to set our parameters. U is equals to 44 meters per second, okay? That is my initial velocity. Now I have an acceleration which is A, and it's given as negative -4 meters per second square, right? Okay, we are looking for final velocity, that is what? V, and we have time to be 10 seconds. Okay, so we are going to use our equation to solve. We know our equation. Our equation is what? Acceleration is equals to v minus u divided by what? T. Is that okay? All right, what's my A? My A is -4. Is equals to, my V is what I'm looking for. Then minus, what's my U? My U is what? 44, right? Okay, divided by, my time is what? 10. So what I'm going to do, I will say that this is over 1, right? I say cross multiply. So what do I do? Now I go by saying V minus 44 times 2 is equals to V minus 44 is equals to -4 times 10, right? Okay, so I'm going to have V minus 44 is equals to -4 times 10 is going to give me minus what? 40, right? Then because I'm looking for V, I'm taking this one to the other side. So this is what? This is equals to minus 40, the sign will change to what? Plus 44, okay? Now when you subtract, minus 40 plus 44 is going to give me 4 meters per what? Second. Do we understand? Okay, let me explain again. A train has an initial velocity of 44 meters per second, an acceleration of minus 4 meters per second square. Calculate its velocity after 10 what? Seconds. Okay? So what is my u? My u is 44 meters per second. Acceleration is what? Minus 4 meters. My u, sorry, is meters per second. Acceleration is 4 meters per second, minus 4 meters per second square. I'm looking for final velocity v, where my time is what? 10. Using my parameters and my formula, I have a is equals to v minus u over what? T. Alright? What is my a? Minus 4 is equals to v minus 44 divided by what? My time is what? 10. What do I do next? I say cross multiply. V minus 44 is this. Minus 4 times 10 is this, okay? Then I will have v minus 44 is equals to minus 40. Then I will carry this minus 44 to the other side because I'm looking for what? V. So what do? I have plus minus 44. I have minus 40 plus 44. So it's going to give me what? 4 meters per second as my velocity. That is my final velocity. Do you understand? Right. U means initial velocity. All right, so I'm going to give you homework now, okay? So I can end the class. Are we done writing? Asakwe done? Faiza done? Are we done writing? Victoria done, okay. Ashiku done. Honor done. All right, let's give our assignment for today. Sorry. This one we have not done this, so I don't want to get confused. Let me give you another one. So let me give you the one you can attempt, okay? All right, so let me give you the one you can attempt, okay? Because we've not done equation of motion, so you don't get confused. So you can copy that. Yeah, there is class tomorrow, our normal time, okay? 2 o'clock. There is. All right, copy the assignment, okay? I have SS2 right now. My time is ticking. They'll be waiting for me. Amadi Light, that should be SS3. How are you? Amadi Light, just stay online. I'll soon come back for you people. You're welcome. All right, I hope you are subscribed to this channel. All right, so give it a thumbs up, and I will see you next time tomorrow, our normal time by 2 p.m. Okay? All right. Thank you so much, class, for sticking and staying to the end of this class. I hope you enjoyed the class. Like I always tell you, the more you solve it, the more you know it's better. Okay? See you next time in my next one. Bye. You're welcome. All right. Bye for now.